Alright, today I've got a little something different on the table. Well, at least different from the last couple of days. I am going to run through the repair of stick drift issues. And I've actually already replaced this once. I was just doing a test with a kind of a known good analog stick, but also it's one that I bought again from a third-party supplier that just didn't work exactly the way it should. The button click, in fact, this mic's fairly sensitive, you may be able to hear it, so that I can push all the way up and the button clicks fine. This one, if you push it all the way up, literally no click. So I use this, and I have a bunch of these, but I use this for kind of just testing when I get a really strange issue. And so it will click, it just at that uppermost top, that one does, this one clicks here, but doesn't click there, and it's really an annoying issue in one of today's most popular games, and that's Fortnite. Manufacturer says that these are made to OEM spec, but they are aftermarket, but they are compliant for working with the PS4 controller, and that's not compliant. So like I said, I put this in just as a test because I know it's a new unit. It does function. The particular issues that were happening with this one, and I even know the cause, is that this stick you could press up and then all of a sudden it would just drop your connection. It wouldn't recognize your signal. Also, it was getting some either inability or intermittent behavior to detect the L2. So basically, once it starts getting wonky signals, it gets just crazier and crazier as time goes on. Now, that's sometimes that integrated circuit that kind of manages signal transmission between all the different components and then shooting it back up to communicate it over USB on the sync side or via Bluetooth. I have actually seen where they work 100% via USB, but will not communicate properly via Bluetooth. And again, that goes back to that probably an IC issue. However, this one was just always jacked up no matter what. And that is because if we open it up, alright, I haven't reattached these yet, but this was actually our problem. This was disconnected and it was touching, and who knows, maybe it was sliding as time went on, but as you can see, this directly translates into up and down movement. And like I said, our most noticeable error that we were having is as we pushed all the way up, it would hold and then it would just drop like you had gone back to center, and it would require you to press up again, and then a couple of seconds later it would drop. So you can imagine using that would drive you insane. So we're going to disconnect this little battery cable here, and this is a cable I've modified. I actually ended up putting back the original connector on it when I had at a previous stage put a different connector on it for who knows what I was doing. But anyways, this was touching. It caused it basically to burn out that potentiometer that is in this circuit. And there's actually two of these. We can take a look at that when we remove this. Let's pull out our touchpad. We want to be careful with this because we don't want to tear it. Without that, you won't be able to use the touchpad at all. And it does have this bit of a lip, so you want to make sure it doesn't catch. And the microscope will come into play here when we're putting these components on, but it is not necessary for the main part, and we're actually going to be using this larger cam, which is why I flipped them for the purpose of this video. And we will reattach this and seal all these back up before we're done. Alright, so here we go. This is what we've got. We're going to take these off. And like I said, if these aren't functioning properly, you usually have one of two issues. You've either got this, which is bad, which here you may be able to see in the microscope. Let's see. You can see I've already removed those there. And then you've got one potentiometer, which is here, another one, which is here, and that was the one that was blown out. And then you also have a switch, which is when you click down, that is what you're actually clicking on. It's a completely separate component, and these joysticks, analog joysticks, are kind of an ingenious mix-up of three different components, and then you have your axis. Now these are spring-loaded in these potentiometers, which is what gives us kind of that force, but a lot of the force is also from a spring down below. It is actually underneath inside of this component. And I should even have one that's been previously torn apart. We could use to show what some of this looks like. So we've got, where are we going? We've got our handle, or the actual stick part of the thumbstick. We've got our outer shell casing. As you can see, the potentiometers are still mounted to it. Didn't bother taking them off. And it's kind of like a resistance coil that's got a bit of a springiness to it, because it is going to return back to 0. And let me just confirm what I'm saying so I'm not fibbing on a video. Actually, no, these are not spring-loaded. They can be. These just kind of turn and change their resistance on those rings. And you probably won't be able to make that detail out, but maybe you can. Yeah, you could see me spin it. So they're not self-repositioning. That actually is happening because when this is in its little gate structure and it's being perfectly supported with all of its little bits and bobs, it has underneath it, that piece I'm not sure or quite sure where it is, but there's the base here, so we can kind of mock this up to a certain extent. Alright, so you got the base, which this sits on top of, this sits inside, but actually in here would be another little stick with kind of like a rounded, think like a tire swing, it's swinging back, forth, left or right, but instead of using just your own inertia and movement of you saying, wee, I want to swing, we don't have any of that. We've got a spring underneath that wants to push that little donut-shaped stick back into its center position. And so when you move it, it's fighting against that spring's kind of center position and giving you that snappy spring back that always returns these back to their 0 position. And that's essentially how your joystick works. And then when you press straight down on that spring, you get your button click. So what we need to do now is go ahead and remove this one that has that hard to press button, and we're going to put on one that fully functions exactly the way it should. And then we've got heat. Alright, so getting the desoldering iron set up. And I'll tell you what, while that's doing that, I'm actually going to go ahead and resolder the ground pins just for the benefit of letting everyone see it, because it takes almost no time at all. And let's go ahead and we're going to get this where it is, right over it. Alright. And just for the sake of not wasting, helps if I turn the soldering iron on. We're only going to do 2 of these. I have actually already done the other side. So that one will not be done in this video. And I'm just going to do these 2 cross joints here for the mount. And we'll take those back out with the desoldering iron. Now, I guess the one thing here that'll be a little bit like cheating is that this has already been desoldered and then a leaded solder applied back on versus the manufacturer's high temp lead free solder, which is a bit of a pain in the butt to remove. And the best way to probably get around it's kind of fight back to, it just doesn't heat up well. Doesn't transfer heat, especially as you can see this is a very thick board. This isn't like cell phone boards are probably half that size, if not thinner. Again, large ground planes, we've talked about this before, I mean, are wrapped around most of these joints is, I mean, there's just a ground plane everywhere. So heat dissipation is rather quick. And that's where the desoldering vacuum pump kind of helps. However, with the manufacturer's native solder that is on there, I find that it's best to put a little flux down on all the joints, go back over them with a leaded solder, and kind of let that flow into the joints because it carries heat a lot better than whatever the manufacturer is using, and then hit it with the desoldering iron. And the way we do this, and I think you've seen me use it before, is we're going to make direct and flush contact with the board. That's what we want. And then we want to kind of use a forward, backwards, up and down, whatever it takes to get, and I don't know if you can see it, but I can feel it. There's a bit of a wiggle to the pin. And once we have that, we're going to, and while still holding vacuum, we lift, and I continue to hold for about a second because I want to make sure that all of that solder that's gone up into the tube actually travels through and gets to the filter. We don't want it getting stuck in the tube, or then we're going to have to use the same little piercing needle to drive it back out so that we can get vacuum again. Basically, you don't want clogs. And so we take this again, we go over the next one. Let's get it in line with the camera, wherever that is. All right. And we give it a wiggle, and we vacuum and lift. And if I look down into it, it is clear. So what we're going to do now is clear the rest of these joints. And these are much smaller than those mounting ones, so they're going to be a lot easier. And that one I did not get. I don't know if you can see that, but yeah, it's not cleared all the way through. So what we'll probably do to fix that is we're just gonna add a little bit. And then before we start the vacuum, we want to work it around again. And now we have that joint fully cleaned out. And controllers are one of the reasons why I went ahead and made the investment in this little desoldering pump. They're just a pain. I don't know if you can tell or if you're familiar with using soldering wick, but soldering wick is something you drag and you kind of slide it around, and you need to work it. You don't just tap it straight to it and it just sucks it right off. And the problem is, and again, this is usually, now if I made some type of a case for this or something to stand it on that was a little more sturdy and suited to the task, maybe it wouldn't be an issue. But if it goes and kind of tilts on you and you've got a solder wick on there and you're hot enough, you're going to end up hitting components that are around it, like these little chips. And it does not take much force at all to knock those off, and you create more work for yourself. Or even worse, it damages that chip, and now you've got to go and source a replacement from another part. So for me, the desoldering iron works best. I also use it on pinball repairs and other things, so I get my money's worth out of it. If you were just doing onesie twosie with this, then I'm probably going to recommend doing the solder wick. It's going to be your most cost-effective option. You're not going to go and buy a $1,000 tool to fix a $60 controller. Well, I guess you could, but wouldn't be a smart investment. All right, so now that that is done, we're going to kind of give it a wiggle just to feel what's going on with it. And it feels like it's still kind of tight, so we want to check these joints. And we're going to look down in them and use the tweezers to see if we're actually free on all pins. See how this moves? You can really, and this one is a little tight, but I think, yep, that's free. It's just, and sometimes they're just barely still bonded to the board, but when you're trying to lift it out, it just makes it a pain. This one's probably one of our problems. It's nice and stuck on there, and it's just that it got bonded to the side. So it's been completely cleaned out. It just needs to be released, and that's going to take the soldering iron to do. This one, I can actually see that there's still some solder down inside, and that one is free. So we've got this that needs to be done, and this one, and that one's going to require additional solder pumped in. The other one will not. Oops. Don't know what I was thinking there. I put the desoldering iron back up, and it is still needed. All right, so again, same method, just put new fresh solder in there and vacuum. And now it's completely cleared out. And with this one, all we got to do is heat up that and then push in the opposite direction from where it was stuck, and that frees it. It may have a little excess there. Let's go with a quick little vacuum. And there we go. Gave it a little wiggle and it comes right out. If you're having to pry and force, you still got something bonded. If you're bending the board trying to remove this, you've still got something bonded. Don't do that. You will cause more damage than good if you are prying on that, or even worse, trying to take a tool and bend it out. If it requires too much force, it's not been properly desoldered yet. And so now we've got our replacement part. And just to show the top side, this is what it looks like. And all we have to do is just pop it in. We want to make sure that we're getting a level seat. And to do that, I just kind of make sure first that it's squared up, and then I hold it just like this to get started. I take my soldering iron, put a little solder on it, and then I just tack it on at the mounting pins. Get another little fresh glob of solder on the tip. And basically going for opposite sides. So we did the bottom left, now we're going to do the top right. Looking underneath to make sure that we're still level and flush as it's pinched, because I kind of reposition my hands there. And there we go. Now once you've got those two sides locked in, that really gets us set for where we don't need to worry about it coming out of its tension or coming out of its proper location. And let's get it lined back up with the camera. And so now we can take our solder and we can just go back to each joint. I don't know why my hands are so shaky today. And now notice this time I went ahead and did them all, but the time before when I was just testing, I didn't do the mounting pins. I actually just did the smaller ones because, again, these require more heat to heat up and free. They're more likely to cause an issue with removal. And just to make life easier, I just needed to see that it works. So I did the contacts that are actually sending signal. These are just for giving it strength in its hold. They're mounting pins, so exactly as that sounds. This one, this one, this one, this one, this one, this one. 1, 2, 3, 4. Those are your essential pins for each of these. As long as those are connected, you're going to get signal. So if you're having trouble with one of these and you're trying to figure out what's going on, these mounting pins are not your problem. Don't spend your time troubleshooting something that's not a part of the circuit. However, if you are testing all of this and everything looks to be good, you've replaced it once or twice and it still doesn't function right, know that your issue is probably somewhere else. You either got a chip, a resistor, a capacitor, one of these little components, or you've got something going on with some of your major IC circuits, which are here, and there's another on the front side of the board. I think we're still on the front side of the board for the Wi-Fi chip. Anything and everything could be a potential cause of the problem. So you got to kind of pull out your Sherlock Holmes hat and start to figure it out. Like I said, in this case, I've already tested it with that initial one. We know that our problem specifically was this one. We've replaced the left side for good measure. The right side was our failed component due to, if you got this wire sunk to here on any of these pins, and you've got this one still hooked up to its ground, not good for the component. And that is exactly what happened here. This one was connected, this one was broken off, so we were basically sinking these contact pins to the ground plane of the board and allowing them to basically just burn themselves out. Alright, so our next step now will be reassembly. And to get that done first, we need to put on our tops, because you can't get these on after you slide it back into the case. So now, well, it's going to be a little bit harder to press when we're not, but now we get clicks all the way up, which we couldn't get with the other one. And that's the original one. It's pushing at the back. So let's go ahead and mount it, and we will show that it now does what it's supposed to do. But before we mount it, let's go ahead and we're going to do this while it's at its most convenient location. And I just use a razor blade to strip these. A wire stripper that actually is thin enough for them. I found one, I just haven't ordered it yet, but I bought 3 in the past and none of them really go that thin. If a manufacturer ever watches this of wire strippers, make some for thin wire that are accessible to the public. And this is being a pain in the butt as well, so let's do it the way I normally would instead of trying to keep things in view. So if you can't see this, I'm sorry, but I can't spend all day stripping a wire. Basically, I'm just using a scratch method to get enough of that off that I can pre-tin it, and I could just burn it away with the soldering iron, but I hate the gook that it leaves behind on the tip. I should probably just set up a cheap soldering iron for burning off the tips of wires. Maybe that would be the way to go about it. I don't mind it with the enamel coated wires on the soldering iron, but this is way thicker and more material than that. And I'm not sure if this does it, but I know certain types of plastic actually eat away at the coating, that nickel plating that is on the tip, which is what actually the solder is binding to. And so the more you use those types of materials on your soldering iron tip, the faster it will expire and require replacement. And we are going to clean this up. And I'm not trying to make this perfect. I'm just trying to get a kind of deep down coating. Some people use hot air on these. I don't recommend it. You're actually going to end up, by the time that it uses the hot air to get anything through this, you're going to heat up and melt away any lubrication, and you could even soften and misshapen the plastic parts that are inside the part of the joystick. And if you heat the board up too much, you can also disrupt these ICs that are floating on them. I think it is this one on the other side. There's one directly above it, so you have such proximity there that you need to be careful how you're using hot air. Otherwise, you can create, again, more issues for yourself than you started out with. Alright, so that leaves us with a fairly clean work area. And now we should be able to see this to tell which one's positive and which one is our negative. I believe it is the reverse from this side, but let's just confirm this with the multimeter. It's been a while since I've taken one apart, and so it's not stained into my memory. Okay, they are separated planes. Which one? Well, for a motor, it really doesn't matter. It's just going to make it spin in the opposite direction. But we want to make sure we get the rumble right. So let's check a reference, because I believe, and I'm going to go ahead and just test this real quick. Alright, so that one does, and I'm wondering if it's just I wasn't on the right pin. Alright, so let's figure this out. Looking to see if I had one that was still connected versus taking my own apart, and let's do a comparison. There. Yeah, I'm pretty sure it's opposite. So this image and this image are exactly the same. That doesn't necessarily mean that they are, but I was almost certain from memory that they were on opposite sides. So we're going to do negative here, positive here. To reiterate that, because I'm not sure if it was in the camera, we had this pad. We're going to attach the negative, because if we look over here, exactly the same, and it is negative. Now again, that's not a surefire way to tell the difference, but as my memory served, it was opposite ends, so I'm fairly confident that that is our negative side. And like I said, also, without going through and kind of checking all the circuits to reverse engineer, it really shouldn't matter. These motors should spin in either direction depending on polarity, and all they're doing is spinning in a circle to create your rumble. If anybody didn't know how the rumble is created, it's the vibration created by a half moon. I like to call them half moon motors. When you only have a motor that has one half of itself, when you spin it around in a circle, it creates a kind of a jarring effect, and that's your rumble motor. Alright, grabbing the soldering iron, we're going to go ahead and mount this. We need some solder on our pad. Get it back into view for you. There we go. And just to make life nice and simple, we're going to put just a little bit, because I don't want to have to go through a ton of cleanup afterwards. Just a dab on each of those tops. And then we're going to take these tweezers and use them to hold our wire in the position that we want it. That takes care of that one. That takes care of that. Alright, so now we do need to make sure that this is laying flat. It doesn't have any rips, any tears. And that when I went and pressed on it with my fingers, that I did not get flux on it. That would be a no-no. If it had contaminants on it, flux otherwise, it would not be able to make good electrical contact, which would result in either misfires on the signal or no detection at all. Alright, so that's that. Then we can come back here. You want to do this face down because there's parts that are in it that if you allow them to move, they are not going to stay. They are going to fall to the floor and you will be picking them up. And we've got to thread this little flex cable back through its socket. Sometimes it likes to be a pain, sometimes it likes to cooperate. And there we go. Just had to get past those ridges. And then you can notice I did the wire direction on, where are we at? Right there. So notice how I flow these wires when I'm bending them and shaping them for how I want them. I try to get them in a direction where I know that they're going to work the best in terms of staying out of the way, because there is going to be a screw that comes down through this little section here, and if we screw through a wire, that's not good. Or is this one not one that, if it doesn't screw in there, we have a contact that's going to be made here. There's also a ring that goes around this, and if it is pinching on these wires, it will cause issues. I've even had problems with putting the battery in. If you don't get it situated just right and it gets pinched, it will close off power to the controller, and you'll be wondering why it's not working even though the battery's plugged in. Well, it's because when you seal the case up, you shut off, you basically choked out its power supply. In that sense, electronics are a lot like people. You get put in a full Nelson, you go to sleep. You're not getting up for a while. Same thing happens to the controller. You choke it out, can't get any power. It'll take you a few minutes to realize what you did wrong, but eventually you'll get it. Alright, so last piece that we're looking for is this guy. Let's see what we can show here. So we've got, and I don't have the back on, I'll actually put this on. I need to test it again once it's done just to make sure everything's appropriate, so I'm not going to bother, but there is an insert that goes over this with a kind of plastic, almost think like fiber optics. So you use fiber optics to, you know, those silly little kind of globe lights that had the funky looking strands coming off of them, and it lights up at the bottom, but yet the tips of all these little plastic wires shine through the light. Well, that's basically like a fiber optic system, and it's just using that fiber to bend the light so that it looks pretty and more fanciful than a single light bulb turned on. Well, in this case, we're doing the same thing, but we have a purpose for it other than just being decorative. When the lights come on in this little spot back here, they probably wouldn't be, I shouldn't say they wouldn't be visible, but they wouldn't be as greatly visible as they are from the fact they use this kind of like plastic light director to move the light into this front area. So you've got a plastic piece that folds over, then you've got a locking tang that kind of puts it all in the right places and gives it pressure. And then you take your communication cord, which is also how it supplies power for recharge. It would greatly help if I reinstalled the battery. And just to show you, here's one, which again, different connector, but this is one I did with a custom battery so that it's double the size. This is a 2000 milliamp battery, and you can find those on eBay, but don't believe what you're seeing. In fact, when we do this one, I had to modify the case to make it fit. It was sitting behind the other one. Okay, there's a height difference, and yes, they are shorter, but in this battery pack, you are not going to fit a 2000 milliamp battery. It just won't happen. If there was a 2000 milliamp battery that fit in this size when they made it, then PlayStation probably would have put it in there. They probably would charge you more for the controller, but they'd put it in there, and they didn't. Reason being, it doesn't exist, and this entire thing is not battery. This is a plastic casing, so the battery is even smaller inside of this. This one is all battery, and that's where I had to kind of shave and trim the case to make sure it fits. And I just want to use this as an opportunity to talk about it because there's people that make a living off of selling bad stuff on eBay, and this is one of those cases. They take a, and I've even been duped by this in the 18650 arena, but they rewrap them, they reskin them. They take the exact same battery and they just change its markings to say that it's something that it's not. And usually when they do that, the way that it happened to me is I bought almost $1,000 in batteries when I was stocking up, and they were all C grade, which means they were used, spent, barely functional batteries that, and if I would have known better at the time, it said that they had 8,000 milliamps. And anybody that knows what an 18650 is will know how absurd that notion is. It's an impossible amount of power to pack into an 18650, which is the size of the battery. The bigger the capacitance you want, the bigger the battery itself will get in respect to the technology. Now, one day in the future, they may shrink battery technology even further, and we could get those sizes in that same format. But that has not happened today. So more than likely, when you buy this and they tell you it's a 2,000 milliamp battery, best case scenario, they've sold you a brand new 1,000 milliamp battery. More likely, and worst case scenario, is that they have sold you a 1,000 milliamp battery that was used for a year or two and then discarded and sent off for recycling. And when they recycled it, they go, we can make a lot more money off of this if we repackage it, tell everybody it's bigger and better than the original, and the average person would never have a clue. They'll know that their battery just doesn't seem to last as long as it should, but they don't know the reasons why and how to express that to the merchant in order to make a claim, which means that usually it just gets pushed off to the wayside, and that seller is a very happy person because they're pocketing all that money from taking something that they probably buy barrels of these at a time for maybe $10, and then they go through that whole scam process of rewrapping them. And there's nothing else to call it other than it is a scam. Alright, so, and again, after going on my battery rant, I forgot to talk about it. Now this is a JDM-040, or I forgot to install it. And you'll notice JDM-040s are smaller. That's what I've installed on this custom battery pack. This one is using the previous version, and this was the connector that was used like in the JDM-001, 011. I think maybe JDM-020, I can't remember, don't get a lot of them, but JDM-030 and 40 use now the smaller connector, and if you put them side by side it becomes clearly obvious that one is bigger than the other. So if you're trying to install a replacement battery that you've ordered from somewhere and it does not fit on the connector, now you know why. It's because you got the wrong version. For this battery, see these circles? There's marks that line everything up. And notice this is what I was talking about with, this battery has to go in here and the wire needs to be a certain way. I just did this for test purposes. This is a test battery, so I'm not really worried about it. But if I was going to deliver this to a customer and we were doing a custom battery on it, my battery cable would be half the size of what it is now so that it fits where it's supposed to. Now, as far as putting that on, the JDM-040 is really easy. It snaps into place. Whereas the, what is that? The JDM-011, there it actually has this plastic piece goes up and over. And it's a bit of a pain in the butt, but you pull it on and off a few times and you'll get it right. You'll get the hang of how to dismount it. But you can actually snap those pieces, and there you hear thing 1 and thing 2 yelling at somebody. Alright, so for the sake of not hearing any more barking, I'm going to go ahead and end this video, but that is literally it for that replacement. I did want to show the one thing. Hold on a second. I'm now going to have to deal with this. Alright, and no, I did not hit my dog. I slapped my hands together, which she does not like the sound of, and that's probably silenced her for all of about 30 seconds. So, for that, we want to hear, or see if we can hear, the click. Oh, we're all the way up, and we're clicking. We're all the way up, and we're clicking. Before, we did not get that, and that was with the aftermarket part that just bad production, and I confronted the seller on it, and they got an attitude. I mean, they got mad. Who am I? How do I know what I'm talking about? They sell these to thousands of people all over the world. They sell tens of thousands of these joystick replacements a month. And I go, well, you're selling tens of thousands of pieces of shit to customers that either don't care because they're installing it for a customer, and as long as they get paid, what do they care? Or they're putting it on and they don't really know enough about electronics to know that there's something wrong. I do this often enough that I knew instantly there was a problem. If I can't push all the way up and click my L3 action that's going to cause problems for me in a game. That is the run feature in Fortnite. If you're a Fortnite player, you're not going to be happy if you can't effectively transition into a run mode. If it was on R3, I don't think that does anything in that game, but there are games that use these on both sides. So for a seller to say that that's normal operation and that I don't know what I'm talking about, blew my mind. And if you've bought these in the past and you have that issue, tell your seller you want a refund. Or if you can't get a refund at this stage, at least tell them to quit selling that garbage and passing it off that it's a compatible OEM part. Those joysticks may work fine in other applications because controllers, well, PlayStation controllers, Xbox controllers, whatever else, aren't the only devices that use them. And in something where you don't need quite the range that you have on this, it'll probably be fine. Because like I said, if you go partially up, you can click fine. But once you go that last part and try to click, that aftermarket does not work. All right, well, other than that, that's it for today. That shows a controller. I'm going to plug this in and test it, make sure that it works. If it does, remember I'm going to pop off that back, reinstall that shield, and then I'm going to place 4 screws in it. There's 2 on the top, somewhere in here. 1, 2, and then down at the feet, or the foot of the handle, another 2. And that is it. Simple as that. Again, this is Circuit Repair Augusta. We also operate under PlayStationRepairAugusta.com. You can find our website if you have a repair for a controller or a gaming console, or for anything electronic that matter. Feel free to contact us, get a quote. Diagnostic for your quote is always free. Once you decide to move forward, we'll get it fixed for you as quickly as possible and back to you.